Now,
looks like some crop circles.
it looks like a lot of things, partner. And what I want you to know about this is that when we talk about self-organizing criticality at all the scales as one of the fundamental defining dynamics that operates across the cosmos, from the finest to the greatest scales, that function operates at the heart of it everywhere. At the heart of it everywhere, because it's archetypal, and we see this archetypal shape everywhere in nature at every scale. You see it everywhere. And there it is, M51. Okay, that's as big as you need to get. And the Fibonacci relationships do what Whittaker said. The masses roll down to the wells and aggregate in these spirals just like they're supposed to. That's exactly what his differential equation says they have to do. But they take the shape of the Fibonacci series. And we see it everywhere. All right. So here's this roadmap that we're talking about. There are simple, elegant rules that operate throughout nature, from the finest scales to the largest. And this is what we think they are. This combination of things we think operate at every scale without exception. The first is this business of punctuated equilibrium. Things go along, go along, go along, and then all of a sudden something happens in a small, bigger, larger, much bigger way all at once. It's not a slow, gradual wind-up. It's equilibrium and then wacko, something big happens. And the experimental verification of this, repeated 10,000 times under controlled conditions, is the construction of a sand pile out of uniform grains of sand. Mm-hmm. So you drop grains of sand, you drop grains of sand, we've played this game, you build a sand pile, you put a stick in it, and you scoop away. You scoop away, you never know which scoop's going to drop the whole thing, right? That's the kids' game on the beach. Well, in scientific terms, what happens is that you sand, 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 up until a very special point, it's just an aggregation of individual grains of sand. But there comes a point at which this aggregation of sand grains becomes a system. And in that system, interesting dynamics happen. Eventually, you're going to have it avalanche off. And what we now know about that avalanche is that you can't predict when it will happen. You cannot predict where it will happen. You cannot predict how big it will happen. And you can't predict how often it will happen. And that's true for every self-organizing, complex, open system in the cosmos. Earthquakes, the weather, the rises and falls of the stock market, they all fit in the same category. You cannot predict anything that these laws prohibit. What you can do is say mass extinctions over time, 2.5 billion years. For every mass extinction event that measured this magnitude, there will be a logarithmic number of smaller or larger events. So that if you take the logarithmic relationship between frequency mappings or magnitude mappings or periodic mappings, what you'll discover is that you get a straight line with a slope. So when you map any kind of data and you get a straight line with a slope, you know for sure what you're mapping is the logarithmic relationship of a complex, open, self-organizing system. And that's a pretty important piece of information, because those power laws then say that what happens with the way this organizes is that all the geometries that result from those physical events are fractal. Not just the catastrophic avalanches, but the self-sustained criticality that creates a brand new thing. And they operate contemporaneously. And in order for that record to be created, we have quantum functions. You have to breach quantum noise thresholds. This much the Standard Model's got right. It is a quantum universe. You can push that stone as long and hard as you want. You can drop dead trying, but if you don't hit that mark and push it with enough force, it ain't going to move. Okay? As that only stretches just so far, but the point is that we do live in a quantum universe. And there's nothing in between, but what the fractal does is describe what happened between the events by connecting them. By connecting them, because it operates logarithmically. And it's not a fraction, it's a fractal. It's parts of a fraction in between functions. It's the magic stuff. All right, so you take these pieces, you connect them with the Fibonacci numbers, whatever gets organized, whatever collapses, whatever happens in these open systems is then defined by Fibonacci relationships. It takes a certain shape. It has a certain kind of distribution. It has certain kinds of archetypal forms. And we recognize those. Then the vector magnetic potentials come into play. And they operate from the 0 point. Albert got that part right. He didn't get it when he was saying it, but he got that part right. That the vector magnetic potential operates from the 0 point, which is the interface from the physical vacuum to the first stage of integration of undifferentiated information that begins to display duality. Because in the physical vacuum, there is no differentiation. Fundamentally undifferentiated by definition, but it is self-referential. That's why it's a fractal, because it's self-similar. It's self-referential, and that has some profound implications for things like the unseen spirit stuff and consciousness and speciation and individuation within a species. The way that works in the non-physical stuff complies with the same kind of laws as the physical stuff. But it all deals with non-local, non-linear field effects. And so we have a very interesting corollary here that now just comports with everything you've described in your presentation. All right. This is the famous Bohm-Aharonov experiment that says even when you block all the magnetic fields, if you exert a non-local field effect, a scalar effect, you still have an effect on the system. It says that there is a ubiquitous distribution of non-local fields in the universe. And now, I guess since 86, 87, most physicists have accepted it, but nobody has incorporated it into the textbooks. This experiment's not in the textbooks. They don't talk about it because it fundamentally alters the model. All right, what is mass? Mass is not an a priori intrinsic property at all, but rather a product of underlying scalar interactions arising from the physical vacuum via the 0 point, which create the effects identified by science in compliance with self-organizing criticality. Mass is a product of interaction. And we're going to show you exactly how that happens. Any of you recognize this photograph? Mm-hmm. Okay. That's a photograph of a solar mass ejection coronal event about to happen. And what you're looking at here are literally electron tornadoes. Huge, gigantic electron tornadoes, except that instead of being like they are on this planet, these babies are pure energy. And it turns the model of science upside down, because what we now know about this is that it is far hotter here than it is at the center. The electric model of the sun is backwards. Whoa. So this gives him real trouble. He's the astrophysicist here. Gives him real trouble. But now we have hard, empirical, verifiable evidence that's pretty close by that says that our notion about how the sun works, that it's very hot at the center and gets cooler as it goes out, is not true. What's happening is that the same functions that operate on the planet in terms of self-organizing events that follow archetypal shapes operate on the sun with the same result. It's far hotter on the surface than it is in the center. And that's not what the model tells us. And it's important because it tells us some things. Look, In 1998, the Stanford collaboration brought together 60 scientists. And they did something that hadn't been done before, and the Standard Model prohibits it.